but I am under the impression that Ms. Cannon touched on this or taught you this last year. Does that sound familiar at all? Cool, then let's go faster this. All right. Can somebody just tell me in plain old English, so fancy math, just what's the big idea of the mean value? What does it mean? Close to what? Tangent, okay, so let's say this one, let's say it two ways. Either tangent slope equals secant slope, or we could also think of it as average rate of change equals instantaneous rate of change. They both mean the same thing. Okay, so let me give you the classic example, all right? So I'm driving to St. Louis to see my daughter, right? And at 8 o'clock on the nose, I'm at this place and I see a cop and I hit my brakes hard because I was going way too fast, and when I pass him, I'm going to nice cool 65 miles an hour, right? Yeah. 1 hour later, I'm 100 miles down the road, and I see another cop. And I see him ahead of time, and I slam on the brakes, and I'm going 65 miles per hour when I pass him. Do I get a ticket?
Sometimes.
Okay, when I saw cop 1, was I going the speed limit? Yes. 65 miles an hour. When I saw cop 2, was I going the speed limit?
Yes.
65 miles an hour. So do I get a ticket?
No.
100% yes. Why?
Because your speed is
For the mean value theorem. What was my average speed?
speeding.
I went 100 miles in 1 hour. What was my average speed? My average speed was 100 miles an hour. Is there any way I can have an average speed of 100 miles an hour by going 65 miles an hour the whole time? No. If my average, hi. Yes. If my average speed, of course cops know the mean value theorem. It's part of the police academy.
No, the cops don't know that you.
What have you done so far?
They may know the mean value theorem.
Second grade?
And I feel like communicate over radio, which tries like based on the mean value
All right. So yeah, the cop says, you know what? I don't care if I saw you doing 65 and that guy saw you doing 65. There's no doubt that by the mean value theorem, the average rate set 100 miles per hour. So there was a time by the mean value theorem when you were going 100 miles per hour. In fact, you had to be going over 100 miles per hour because you were going 65 when you saw me. So you had to compensate by going more than 100 miles per hour later. That's the mean value theorem. So, ticket, you're busted. You're busted. I'm busted, actually. All right, so the mean value theorem then is the idea in math terms that if a function, there are conditions, if a function is continuous on a closed interval and differentiable on the open interval, I'll explain why that has to be the case, there must be at least one, not exactly, at least one point where the instantaneous rate of change at a point, at an instant, obviously, equals the average rate of change over an interval, or over 2 points. Okay? Plain old English and math and definition. Now, I'll graph up this idea. Would you graph me, put a dot and graph me some kind of positive cube shape and put another dot? Height?
Height.
All right. Now, the average rate of change would be the slope between the endpoints. That's the secant slope. Is there some place on the curve where I could draw a tangent slope that's parallel to that?
Yes.
How many? Two, actually. In this case, there are two. There has to be at least one, but in this case, there's two. Would you call that C1 and C2? C typically represents the instant at which you're drawing a tangent, and A and B are typically the endpoints. It's arbitrary, obviously, but that's pretty common. All right? Why is continuity necessary? Well, would you Draw for me the old hyperbola function or rational function there, yay? And would you call it endpoints at, let's go endpoints at about 1 and there. You with me?
Yes.
So it's continuous, it's on the interval -1 to 1. There's your A and there's your B. You with me? All right. Where is the average rate of change between the endpoints? Oops. Isn't that the slope between the two endpoints? Okay. Is there a point where you can draw a tangent slope like that?
No.
No, every slope is negative. These are negative, these are negative. There is no place where the slope is like the secant slope. Continuity is necessary for this to stand. Okay? Furthermore, would you draw a parabola with two endpoints that level off at the same place? And then would you also draw me a Siegel function with the endpoints also the same place? Illustrate the differentiability, right? Now, if I were on the first one to say, what's the average or secant slope, what does it look like? Hey, that's pretty special if the secant slope is 0, because that would imply that the original function has to have a horizontal or a horizontal tangent, which probably means extremely, huh? In that case, this is the case. Isn't there a place where there is a tangent slope? So here, MVT applies. And that's because it's differentiable and continuous. Right? All right, now if you consider that same idea for this, that surely the average slope again is 0. And yet, is there a place here where the slope is 0? No. Okay, so MVT does not apply, and that's because it's not differentiable. Did I see anything in your notes about why you closed interval, open interval stuff? I'll get it. The next one's a squared function. I'll get it in them. Okay, you might, if you're a really careful reader, you'd see it has to be continuous on the closed interval. That means it has to include the endpoints, but only differentiable on the open interval. Now, most people can understand why it has to be continuous on the closed interval. Can you imagine if it wasn't continuous up to the endpoints? Well, then this whole thing falls apart. F at B minus F at A, if they don't exist and there's not continuity at the endpoints, then it's hard to do this whole thing. Why differentiable on the open? I'll talk about that in a second, or not. This portion. Is this the next thing? This is the next thing? Okay, cool. So, for the following problems then, does the mean value theorem guarantee a point where the instantaneous rate of change equals the average rate of change? This is basically what I'm going to ask you to show. Let's just use a little abbreviations, but almost full sentences. F is continuous on -3 to 3. Do you agree that that's true? Actually, I should have asked you first before I just made you write it. Is the parabola continuous on the closed interval?
Yes.
Parabolas are continuous, so no worries. What about, is it differentiable on the open? Does the derivative exist everywhere, including -3? Okay, so I would say then that MVT does apply. There is a place where the tangent slope equals the secant slope. You follow?
Yes.
Okay. Try the others then. Tell me if the MVT applies or doesn't apply, and if not, why not? so? Why so? Okay. Okay. For the second one, do you agree that tangent is not continuous on the interval? Okay, so therefore we say MVT does not apply, or not guarantee at least a point. There still could be such a point, but it's not guaranteed. What about the third one? Is F continuous on the interval?
Yes.
F is continuous on the closed interval. The more you write it, the more you'll remember it. Continuous on the closed. Differentiable. Isn't the derivative 1 over 2 root x? And does the derivative exist at 0? It does not. But does it have to?
No.
It does not. F is differentiable on the open interval 0 to 9. Let's pause and see what the heck is with this closed interval, open interval stuff. When you do the square root function from 0 to 9, you're trying to say, if I connect the endpoints, is there a place where the tangent slope is the same? Now, I think you'll agree that the derivative doesn't exist at that point, but that's okay because the point at which we're doing this mean value theorem is interior. And so it doesn't matter that the derivative isn't smooth or awesome there. It still applies. So endpoint doesn't keep you, differentiability at the endpoint doesn't keep you from getting this done, all right? So this MVT does apply, or guarantees such a value. In a second, we'll actually find the value. What about the last one? Is F continuous on the closed interval?
Yes.
F is continuous on the closed. Is it differentiable on the open?
No. Yes.
It is not differentiable at x equals 0 because there is a right. There's a vertical tangent. Okay, there's a vertical tangent there. The derivative has 0 in the denominator there. It's a vertical tangent, and so MVT does not guarantee such a point or does not apply. All right. Now that said, you might, if you know the graph of this, it looks like this. And the tangent slope looks like this, or the secant slope looks like that. And there actually is a point, technically 2, where the MVT, where you have a tangent slope. It's just not guaranteed to be there all the time. Sometimes it happens anyway without the conditions. It's just not guaranteed. So the key word is are guaranteed to be such a point. It doesn't mean if it doesn't meet the conditions, it can't still happen coincidentally. It's just not going to happen. All right. Man, this board is just kinky today. Okay, or not. Okay, los siento, mijos. Is this what's on your notes next?
Yes.
All right, great. So after you say, yeah, the MVT applies here, it fits. then it's often the case that you need to say, all right, find the place where the tangent slope equals the secant slope. So, case like this, especially with the work I expect, all right? Given a square root function, must there be a place on 0 to 4? It's a lot of symbols in here that tends to intimidate people. Must there be a c that is an element of 0 to 4, or in the set from 0 to 4, such that f prime at c is a half? If so, find the c value. Now, this kind of reads funny. You can see that it doesn't say anything about use the mean value theorem to do this problem. And it doesn't say, is there a place where the tangent slope equals the secant slope? There's nothing on the surface here that screams, use the mean value theorem. You have to know the code, okay? Does there have to be a place where the derivative is 1/2? I look at that and go, why? Sure, I guess. Why? Why not? I don't know why. So I'm feeling, if you ever read, must there be a place where the derivative is something? Must there be a place where the derivative is something? Then think MVT. Now this is going to have to require you to balance things, because there's also a question you learned way back when it said something like, must there be a c in 0 to 4 where f equals a half? What would that be? That's intermediate value theorem. So just how this one little thing makes you go to a totally different direction. Okay? If it says, I should have written this in, must there be a place where f equals a point? That's IV. If it's must there be a place where f prime equals, think MVT. Now, only thing I have to hope is, I hope that average rate of change equals a half, and that's why they're telling me a half. You with me? Yeah. All right, so right now, I don't exactly know. It's just, if you're thinking, where's it going with this? I don't know either. Let's just pan ahead, and I'm thinking, all right, it's MVT. Let's see, first of all, does it apply? Does MVT apply? That's the first thing you need to show. So, f, is it continuous on the closed interval? Okay, so you need to say, I don't mean if you abbreviate CONT on 0 to 4. On the AP test, I hope you would actually say that. I also don't mind if you, is it differentiable on the open? Yeah, the derivative is 1 over 2 root x, which is fine everywhere except 0, but it doesn't have to include the endpoints. Open interval, so we're cool on the second condition, 0 to 4. You with me? So it's kind of like by L'Hopital. You're saying, hey, the conditions for this theorem I know have been met. And so then you say, okay, so by MVT, there is a place where the derivative at some point in this interval you're talking about equals f at, now you could say generally b and a, but I typically just go to the interval at hand. In this case, it's the average rate of change on the interval. What's the average rate of change on the interval? F at 4 minus f at 0 over 4 minus 0. Like I said, I hope this is coming out to be a half, because otherwise I don't understand what the heck they're talking about, right? F at 4 is 2, f at 0 is 0 over 4, and so surely there must be a place where the derivative is a half, all right? Now this really has two questions if you read that. Okay, what two things are we supposed to do? Show there must be a place. Did we do that? Yeah, by MVT there's got to be a place in the interior, right? But now they say, all right, now find it. Now I need to find it. Okay, so find it. Find what? What am I finding? C. I'm finding C. It says find C. Right? So find C. Well, what do I need? Okay, the derivative I know is 1 at C is 1 over 2 root C equals 1/2. I know the derivative at this point is supposed to be 1/2. Well, let's see, makes that true. You can probably just see by guess and check, see it has to be 1. And there you go. Now, if you're a visual person, you want to confirm that. Cool, it's saying here, from 0 to 4, is there a place where the slope is also 1/2? And that 1 makes sense. It's logical to me. You with me? Okay. You try what, please? I still expect you to show the conditions are met anytime you use the MBT. Even if it says use the MBT, I still want you to show the conditions for its use of them. How are we doing? Ready? Okay. Do you agree that although 1 over x definitely has the possibility of discontinuity for the interval they're talking about, we're good to go? Okay. So it's continuous on 1 to 4. Closed. And differentiable, again, on the derivative is negative 1 over x squared, which could have problems, but at 1 to 4, we're fine. Okay, so we're good to go on the conditions, right? Okay. I tend to do this like I was taught to do, which is to say work one side and then go back and work the other. Students tend to want to do this quicker for good reason. And so if you didn't first find the average rate of change, then, is that the derivative? That's the right derivative, right? Are you with me? Then do the derivative. If you work both sides, for example, if you have negative 1 over c squared, you're working both sides of the time. I'm okay. But what is c? Plus or minus 2? Or just positive 2? Why not negative 2?
Not in the domain.
It's not in the domain of the function we're talking about. It's true, but it's not the point. Right? It is there. I think there's a point to this one. I can't remember what, but let's go. Is f continuous on the closed? Is this on your notes? Okay. Is this continuous on the closed? Yes. Is f differentiable on the open? Do you agree the derivative is 3x squared minus 1? That has no problems anywhere. Yeah. Okay. Therefore, the MBT applies. And so by MBT, there is a place C between negative 2 and 2, such that the derivative at that C is equal to the average rate of change between the two endpoints. Okay. Do you want to work both sides at a time, or would you rather find the right then find the left? Let's just do both at the same time. What's the derivative at C? 3c squared minus 1 needs to equal, and the right-hand side, what's f at 2? 6. What's f at negative 2? Negative 8 plus 2. That's negative 6, yeah? It's odd, so that makes sense. All right, you with me? 3c squared minus 1 equals, what's the right-hand side of the average slope equal to? 12 over 4 or 3, yeah? So 3c squared is 4. So c is plus or minus or just plus? Plus or minus. There are two places here at 2 over root 3. Plus or minus. Follow? Okay. Sometimes there are two places. Remember the theorem says there's at least one place, not exactly. Okie dokie. Darn it, I keep hitting that button. Is this the next thing? Yes? Okay, did you do Rollet last year? Alright, Rollet is a special case of the mean value theorem. And it goes a little something like this. If a function is continuous on a closed, differentiable on the open, and f at a equals f at b. Now, that means that the y endpoints are at the same level. So it might say it starts here at a and does its dipsily-do and ends here at b. They're saying the y values are the same. Now, if the y values are the same, then what's the average rate of change part of the MDT? Must be 0. And so what does that imply? There's got to be a place where the derivative is 0, okay? That's Rollet's theorem. It's really a subset of mean value theorem. Rollet requires 3 conditions met. Okay, so say something like this. Oh, darn it. That's what I did over there. Sorry. There's got to be a place where the derivative is 0 at least once. Sorry, I don't follow my own notes, and I made them. That's dumb. My bad. You with me? Okay, so let's say, show the 3 conditions for Rollet's theorem are met and find the c such that f prime is 0 for this function. So, what are the 2 conditions for mean value theorem? F is continuous and differentiable. Continuous on the closed, it's got to include the endpoints. You can't draw the average slope between them if there's no endpoints there. And F is differentiable on the open. It doesn't matter if the derivative exists at the edges, because we're just going to talk at some point inside. And for Rollet, I also have to say, oh, this is that special case where the endpoints are the same. So I have to say that f at negative 3, which equals what? 5 equals f at positive 3. Because those 3 conditions are met, we could say by Rollet, f prime at c must equal f at 3 minus f at negative 3 over 3 minus negative 3, which equals 0, yeah? Are you with me?
Yes.
Am I done? No, it says find the c. All right, so now I do need to do, okay, where is that point where there's a horizontal tangent? What's the derivative? Yeah, at c. 2c equals 0 at c equals 0. Are you with me? ¿Entienden? ¿Comprenden? Which one is it? Both? ¿Entienden and comprenden ustedes? Oh, muy bien. How do you say do you understand in French, Lindsay?
What?
How do you say do you understand in French? Tu comprends? Really?
Yeah.
Oh, tu comprends? Like that?
Pretty much. That's French.
Like I said, anybody can speak French. You just pretty much talk like you got a mouthful of market.
Pretty much, yeah. Like you have to pronounce you of the syllables. Yeah.
Sans comprendre?
Yeah.
Huh? Oh, no, yeah.
Syllables, some more French ones.
Yeah. Tell Mr. Saab I speak French. All right, are we good? Is that the end? Oh. Okay. Do you say we learn that the first day? That's the most
That's just
important.
every day.
Every day you say,
Every day we have practice.
Questions on 84? One. One and three is 10. 21.
I was having a fantastic.
I managed to myself very confused. I don't really know what I was doing. Do you have an intro? Last time you tried to help me, didn't
I know that case equations were so bad in cases. I know.
Don't go to college, Skylar.
Okay.
Yeah.
Number one, is that replaced or straight up book?
Straight up book.
Straight up book, number one. Yeah. Yeah, those optimizations, they're stinker. Okay. So, if I recall, they said you have a square field and a rectangle field. And this is y's, and this is x's.
That's the whole thought. I don't have complete thoughts.
Okay. I'm betting that the answer to this problem is communism. Let's see. All right. So, communism. I'll explain. So, here's the deal. You have the square field has to be at least 100. Area is greater than or equal to 100. And here the rectangle field has to be greater than or equal to 75. 75. All right. I felt like the hardest part is A, the endpoints. This is going to be an extreme value problem, but they don't even give you the endpoints. They say make your own endpoints, you weasel. So the max and min values of x, the min x is pretty straightforward. The min x comes from the minimum area of the rectangle. And so you might have been able to say, well, the minimum x has to be what? 3x squared has to be at least 75, so that implies x has to be at least 5, yeah? X must be at least 5, otherwise the rectangle field's not big enough, right? The harder one by far is the max x. Let's start here. Why can't x be as big as it wants? Okay, they say you only have 120 meters of fence, and so you are limited there, and then you have to give some to the y fence because you need at least area of 100. So tell me this, what does max x have to do with y? X will be at its max when y is min. Oh, perfect. All right, so what is y min? Min y equals 10. What does that leave? So how much is used for the square? If 10 is y, then what's fence used for the square? 10, 10, 10, right? 40, right? Okay, what's left for the x field, for the rectangle? 80. So that means what's x? 10. Okay. X max is 10 because 3x, 3x, 2x, or x and x is 8x. You need to have at least an x of 10, or at most an x of 10. You with me? So x is between 5 and 10. Do you see where I'm coming from there? Okay, those are your endpoints for the EET. Express the sum of the fields in terms of x only. Surely the area is y squared plus 3x squared, and that's not in terms of x only. So what's another relationship for x and y? 120 meters of fence is to be used for 4 x's and, or sorry, 4 y's and 8 x's. Should I solve that for y or solve that for x? Y is 120 minus 8x over 4's, so 30 minus 2x. Okay, so the area function in x only is 30 minus 2x quantity squared plus 3x squared. Distribute it out or just take the derivative away? Whatever you want. It's probably the same either way. So now it says find the absolute we trying to maximize absolute max area, yeah? And that's at endpoints or critical numbers. Critical numbers are where a prime is 0 or undefined. What is a prime? I agree. I see what you're saying. Negative 60. I can get you there. I'm getting something like. So I'm distributing negative 4, so I get negative 120 plus 8x plus 6x. Please stop me if you're getting something different. 120 equals 14x. And so 67ths, that's funky, which is 8-ish. And that's in the interior, yeah. Okay, so now I gather the candidate. I got the candidates, the endpoints, and the critical number. The area at 5. The area at 5 is 30 minus 10, which is 20. Squared is 400 plus 75. I'm getting 475 there. Do you agree? Okay. The area at 10, I'm going to dance around 67 as long as possible. Maybe it'll go away. At 10, 30 minus 20 is 10. Squared is 100 plus 3 times 10 squared, that's 300. That is, I'm getting 400 for the other endpoint. You follow? And the area at 67, so you do it by hand. How much energy do I have? 30 minus 127 plus, geez, the freaking ways, 3 times 3,600, 49ths. Please say no. Golly, 210, 97ths squared plus, geez, the freaking ways, 10,800, 49ths, 8,100. Geez, 18,900 49ths. Nope. 81. Yeah, that's right. Yeah? What is that?
Really good.
7. Does 7 go into that? 49? Oh, 7 goes into that. Super. 7 is 2. 40 is 7. 0, 0. 2,707? Okay, what is that equal to? Roughly, that's what? 3? 60, it's 380 something, it's not it. Alright, so what's the max? Max area if the square field, if x is 5, yeah? And so if x is 5, then this field is 5 by 15. And that leaves me with how much for the other guy? So that's 40, 80 for this guy, 20 by 20, yeah? Cool. Okay, so like I said, the best area is communism because it's the most equitable distribution of resources, yeah? All right, the most equitable is the most efficient. Okay, please don't go tell your parents I said I'm a commie or something, please. I don't want a bunch of emails saying they're communists. Number 10, question on 3 rather. Question on 3. All right, 3. A ball is thrown horizontally. When they say find the height, sometimes it says, you have to read carefully, especially lazy people are pretty good at reading carefully. Sometimes it says write the equations, in which case I'm okay if you write. But if it says develop them, then you got to develop them. And this one doesn't say either, quite frankly. It just says find. All right. So I'm going to go through this slowly just for the sake of education. Do you agree that velocity is the antiderivative of acceleration? And therefore, velocity is negative 9.8 t. Is this meter? I should check. It's meters. Okay, phew. Plus a constant. It says that it's thrown horizontally. So this is a horizontal or a vertical equation. This is a vertical equation, okay? It's about acceleration due to gravity. That's up and down. So if he throws it vertically, then what's the, or sorry, if he throws it horizontally, then what's the initial velocity vertically?
0.
0. If he throws it horizontally, there is no initial vertical velocity. I'm not throwing it up, so it has positive vertical velocity. I'm not throwing it down. There is no vertical velocity. Horizontal implies v equals 0. So v is negative 9.8 t. That was, to me, the hardest part of the problem. After that, then, height is the antiderivative velocity. That's negative 9.8 over 2, so negative 4.9. T squared plus a new constant. Do you agree with that? Says it was thrown from a 100-meter tall building. So at time 0, the height was? Time equals 0. The height is? 100. So the height is negative 4.9 t squared plus 100 at any given time. That's how you find the height. Are you with me? Okay, so I found the height equation. Checkity check. B. Was that the problem, or shall I continue with B? How will you find when it hits the ground? Ground when? When height equals 0. Solve it by quadratic formula. You may use a calculator. Okay. Please don't just write that on your paper and leave that. I hate it when I say solve it in the quadratic formula, and on the paper people write solve it by the quadratic formula. I mean, you solve it by the quadratic formula. Understand? Okay. So if the horizontal velocity is 20 meters per second, okay, what's the horizontal, the distance the ball will travel? Beautiful. Now this is actually getting towards parametric equations, which we'll talk about later, but it's thrown like this. Okay, so horizontally speaking, the horizontal is how fast it's going times how long, yeah? Are you with me? So its change horizontally is its rate, which is 20 meters every second, times, how many seconds? How far is it going to go horizontally before it hits the ground? Well, I know it goes 20 meters horizontally every second, and gravity doesn't affect that. It goes 20 meters every second horizontally, period. How do I find, though, how long it's in the air?
The time.
Yeah, you actually need this part. You need to find the time it's in the air before it hits the ground, and then once you have that, you multiply that by how many 20 meters every second, and that tells you how many meters it travels horizontally. All right, and 10. Is 10 still a question? Anybody need 10? Okay, 10. Replaced or straight up normal? Okay, so we distinguish first of all, is this kind of a normal recall derivative, or is it a U-sub problem, or is it an odd power even power? So it's even power. Okay? It can't be U-sub. So when it's even power, you use the power reduction identity. 1/2 minus 1/2 cosine of 2x. Okay? Right. And then 21, does anybody need 21? Okay. All right, 1 to 2. I don't really know what the graph looks like to this, but I do know that on 1 to 2, both of those are positive the whole time, so I can be confident that I don't have negative area thing going on. I would just do this by integration by parts.
And he was the same kid that
Both had it later,
controller and touch it.
and then you're good to go.
Yeah.
Okay? Have a great day, people.
He also really badly What do you need? I think we'll talk with you. I like
So I feel like, yeah, you should be able to, so I think I'll probably be It's like you're like issues. Sorry, I didn't. Alright. So good question. This one's hard. Not only do they hack away, but there's also a vertical aspect there.
Sit down.
Because there's still another x plus 1 in the denominator, that actually contributes to vertical aspect. So the whole actually isn't an issue with vertical aspect. Okay. Have a good day.
Mr. Rickman, I am the most absent-minded person in the world, and I don't know how to turn homework